So look, I don't know if you're anything like me, but I'm having something of a change of heart. So I started this week quite clearly with OpenAI Agents SDK as my favorite, and obviously with Crew as my second favorite, and being a little bit skeptical of LangGraph because you sign up for a lot. But I'm coming round. I'm having a really great time. And what I've got to show you today, I feel like you're going to be there right there with me. I'm actually becoming a serious fan of LangGraph, and there's some really cool stuff. So see what you think. I'm suddenly feeling treacherous against OpenAI Agents SDK. Welcome to week 4, day 4, introducing a new project, Sidekick, and I can't wait to tell you about it. So what are we going to do today? How are we going to go deeper? You know, we always go a bit deeper with each of these. So first of all, I'm going to unveil a new tool, which is going to be incredibly powerful and which is going to allow us to do very different things. We're going to talk about structured outputs, something that that's been a recurring theme. We've done that in each of these. We'll use it here too. And we're also going to build a proper multi-agent workflow in LangGraph so that you see it really coming together. The equivalent of the handoff in OpenAI Agents SDK or having a crew of agents. We will be doing that. And as a reminder on the diagram I did last time that brings it all together, remember the terminology, a super step is a complete invocation of the graph, and each super step represents like one user input coming in and then flowing through your graph of agents and tools. And then those blue diagrams are representing the graph that gets executed. The state is managed through that graph, and reducers are called to make sure that the state object, which is an immutable object, is maintained and managed through that. But between the super steps, you use checkpointing as your way of maintaining state. And checkpointing is very powerful, and it lets you do things like rewind the clock and put your state back to any prior point. So with that quick recap, let's go to the lab. All right, so we get started in week 4, and we're going to go to lab number 3, week 4, day 4, lab 3. And it's, as I say, the start of an awesome project. I am super happy with this. I hope you will be too. We do some imports. Takes a while. There's a lot of stuff to go. And then we've got this empty cell here. Why have we got an empty cell? Because, of course, we have to do load.env. Override is true. This is second nature to you at this point. Okay, so I also going to introduce this time asynchronous LangGraph, using LangGraph in async mode, which I promised was going to happen this week. And it's very similar to using LangChain in sync mode. When we used to call tool.run to run a tool, you can now call await tool.run to run the tool asynchronously, but passing the same inputs. Otherwise, it's just the same. And to invoke the graph, if we would have said tool graph.invoke state before, we can now say await graph.ainvoke state. So that is just simply a way to run LangGraph in asynchronous mode. And that is what we're going to be doing. For the state, I'm going to again be using a typed dict. So that means that it looks very much like when we use Pydantic objects. You just have one field I'm going to have called messages. It is annotated. The type is a list. And this is telling LangGraph we want it to use add messages, which is a canned function that you can import. We want that to be the reducer, which is going to keep on adding messages whenever we return that as our state from a node. And we will start a graph builder with that state. Okay, so far so good. Okay, next up, we are going to create a tool that we did last time, so we can do it nice and quickly here. It is the push notification tool. We define our function push, and then we wrap it, package it in a tool called tool push, which describes what it is. It calls the function, and that is all we need to do. Okay, now it gets exciting. Playwright. Do you know what Playwright is? Playwright is one of these browser automation bits of software. It's considered the next generation of Selenium, which many people have used. I've used Selenium an awful lot. Playwright is by Microsoft, and it's a very nice framework for running a browser, and it's originally used for testing. So it's used for test purposes. And a lot of people also use it for web scraping, because if you just try and request a web page, you just get back like the server content. If you use something like Selenium or Playwright, you can actually render it in a browser, run the JavaScript, paint the page, and then use that to actually get the content. So Playwright is a powerful a tool for running a browser window, and it can do so what they call headless, which means you don't even see the browser window. It's just like running behind the scenes, or not headless, headful, in which case you see the browser screen yourself and you can interact with it. So that is Playwright. You may already know it. A lot of people use Playwright. This is how you install it. You type Playwright install to do it on Windows and Mac OS, or on Linux. It's this longer command, and it will then be installed. And if you have problems with that, then let me know, but hopefully not. Okay, one other thing to mention, one other little detail here, and this is just for running it in a notebook. One of the challenges with async IO is that async IO runs an event loop. And when it runs an event loop, it runs this thing that's just constantly making sure that it's running anything that's being awaited. And then when it's holding on IO, it runs something else that's being awaited. And one of the problems is that async IO only supports one event loop. And if there's an event loop running, you can't, within that event loop, run another event loop. And we're running an event loop as part of running this notebook right now. And so that can cause problems when you try and kick off async processes within async processes. And so there is this package called Nest Async IO that's quite popular, which you can just simply use this, and then it like patches async IO so that you can have an event loop within an event loop. And as you will soon understand from me prattling away, we're going to want that because we're going to want to run Playwright asynchronously, because we're going to build an agent that can drive Playwright. And so we're going to need that concept of an event loop within an event loop. But when we later put this into Python code, we actually won't need this anymore, but we'll need it for now. All right, that's a long sidebar that's over. But now comes the magic. So one of the incredible things about LangGraph and LangChain, well, I'm becoming a convert of both, is that they come with so many great tools out of the box. Many of them are in the community package. There's actually a couple of different ways that you can run Playwright. There's two sets of tools. One of them is a more simplistic one that's just a bit high level. This one that I've got here, the Playwright Browser Toolkit, this is a lower level set of tools which provides a bunch of different tools. Let's just, we're gonna create this. So this is creating an asynchronous Playwright browser, and then it's building a toolkit from that browser. And now we've got the tools into a variable tools. So I'm just going to print these. And here are all of the tools that we get in this package. We get something that lets you click on an element in a web page, navigate the browser to a particular web page, go to the previous web page, like press the back button, extract text from a web page, extract hyperlinks, get elements, and then the current web page. So it gives you quite granular control over what's going on in this Playwright browser. So again, to recap, Playwright allows you to launch a browser window, and then this LangGraph or LangChain set of tools gives us a series of tools that will allow us to interact with that browser, open windows, navigate, read the text, read the elements, do that kind of thing. That's pretty cool. And that is something we're going to be able to arm our agent to be able to use. Okay, so next we're going to actually put these tools to good use. So this thing here is a neat little bit of Python called a dictionary comprehension. You might be very familiar with it. If not, check out the guides. We put together a dictionary by iterating through tools and creating something where the key is the name of the tool and the value is the tool itself. And that allows us to pluck out the navigate tool and the extract text tool from this list of tools. And we're then going to call the navigate tool asynchronously, navigate tool.arun with the web address for CNN. And then we're going to call await to extract the text from it and call this. So this has got nothing to do with LLMs. This is all about running Microsoft Playwright with the tools that come with LangChain. And we'll run that. Up comes a browser. It turns to CNN and stuff is happening, and that just completed. And isn't that cool? It was like, I know it's got nothing to do with AI, but it's just great technology. Come back here and we print the text, and there we go. We've got the text from CNN. Impressive stuff. So we can now package this together into one collection of tools. These tools that we just got from Playwright plus our push notification tool, in it goes. And now it's time for us to make some agents. So the first thing we do is we do some pre-work to create our LLM, which is GPT-4o Mini. Feel free to switch in your favorites. And then we bind it to tools. This, you remember, is what we do to deal with creating all of that JSON for all of these tools. We've got a whole ton of tools now. JSON will be built for all of them. And now this is our chatbot function. This is something that is going to be one of our nodes, because a node is just a function. And it's something which will call, it will invoke LLM with tools, passing in the messages, and what comes out will be shoved into messages and returned. And that, of course, is our new state. And the reducer will be used to combine it with the old state. So let's execute that. That's great. And now we have our graph. I think this is probably makes more sense to go here, just to be nice and tidy. So we create our graph builder with the state that we've specified. We add the chatbot node. That's this function we just got here. We add in our tools. We then add in a conditional edge. This is going to be the if statement implemented behind the scenes. If the tools condition is true, then tools will be called. We add an edge from tools to chatbot, and then we add from the start to the chatbot. So I said it's agents. It's only one agent. That's it. We get some memory. We compile with that memory, and we draw our image. There it is. It's an image we're familiar with. It's the same as last time. The only difference is that these tools are a bit meatier than we had before. We now can control a browser window. Okay, so here we have at the end our Gradio flow. So we're going to create a Gradio interface. We're going to use a function called chat as our callback. And here is chat. It's an async function. Gradio supports functions, its callbacks being async or being sync. And it's we're going to just simply call our graph that we've already built. We're going to call ainvoke, the asynchronous version. We pass in our first state, which is the user input. This is a super step. So every input is like another run of the graph. We pass in the config, so we have memory. We don't actually use the history because we're relying on checkpointing for that, but Gradio sends it to us anyway. And that is our Gradio code. And with that, let's run it. There it is. Okay, let's say hi there. Okay, let's say please send me a push notification with a news headline from CNN. See what happens there. There goes the browser. I'm not touching it. Hope you're expecting that. We got a text. I could see the push, and it says indeed this push notification about news going on. Very cool. All right, let's try another. Please send me a push notification with the current USD GBP exchange rate. The browser is still running behind. Let me just bring that up. There it's gone to an exchange rates page. And we got the push notification. There it is. Yep. And it is different than yesterday. Down by a little bit, 0.77 instead of 0.78. That's amazing. So there you go. There you have it. That is a really powerful tool in Playwright. And isn't it amazing that we've now armed our agent to be able to drive a browser? And you can start to see, when you think of the excitement people have around things like Manus and this idea of agents that can drive, you can now see how this could become an agent that can drive a browser and do work for you. And of course, that is what we're coming to for this week's big project. And I thought it'd be nice to just bring this up in Langsmith for a second to show what it looks like. Here we have it. You can see, if you look, that there was a fair amount of interactions that went on. The process of going around the browser and doing various things, it takes a little bit of interaction. It takes, of course, doing some navigating and reading. And if we look on the right, we can see what happened here. This is the human making that. So I said, hi there. It said, hello, how can I assist you today? Please send me a push notification. And then you can see it called to visit, navigate browser to CNN.com. So I think I just said CNN. So it knew to look up that web page. And then it knew to navigate. It extracted hyperlinks. It looked at some hyperlinks. It did some stuff. And then it ended up sending a push notification. I noticed that I've got the tool returning just null, which is probably a bad thing. I should have it returning like some fake JSON that says success or something, so that it doesn't so that it just sort of lands better, more coherent with the call of the tool. So I will make that change. And then you can see that it then goes to exchange-rates.com. It pulls that out. It gets the results. It extracts all of the text, and then once more, it sends a push notification. So it's great to see this trace. And then you can see some other information about this too. I think I got to see over here, the total number of tokens that were exchanged with GPT-4o Mini, and the fact that the total cost was 10 cents out of, oh no, that's from all of the runs. I was going to say that would be expensive. And I've been doing a lot of runs. So you should not have spent 10 cents. That was, in fact, 0.8 of a cent for that whole conversation. And if you've been using Olama, then it wouldn't have cost you anything, but you might have had more coherence issues because we're expecting a lot. You probably have needed to use a larger model, but certainly worth experimenting with. But if you chose to splash out and use GPT-4o Mini, it would have cost you all of 0.8 of a cent. You can see that these things, and obviously they can rack up over time if you use it extensively, but for any one given call, it is relatively low cost. And so here we are back in Cursor to go to lab 4, because this is a day when we do 2 labs in one day. Week 4, day 4, preparing for tomorrow's big project, which is called the Sidekick. And it's time to introduce structured outputs and a multi-agent flow. So we got a bunch of imports, and we are going to set our load.env as usual. And now we're going to be using structured outputs. And you'll remember the first step with structured outputs is to define the schema. What are we using to describe the results that must come back from an LLM? And in particular, the thing that we're going to be working on is an evaluator, something which is going to decide whether or not an answer from an LLM is good. And so our evaluator is going to respond using this object, an evaluator output. Well, really, it's going to respond with JSON, and the JSON is going to have to conform to this. So we just describe what this means. There's going to be a field feedback, which is going to be feedback on the worker's response. Success criteria. Actually, let's change this to the assistant's response, because that's going to be more words that it will understand. Worker is what we will call it in this assistant's response. There we go. Now you get to see me type. So feedback on the assistant's response. Success criteria is whether the success criteria has been met, and user input needed. True if more input is needed from the user, or clarifications, or if the assistant is stuck. So this is going to allow, we're going to have an evaluator that's going to evaluate the results of our worker, the assistant, to use their terminology. And it's going to decide whether it's okay to forward that back to the user, or whether it needs to go back to the assistant for more work. And one situation is if the success criteria are met and it's done its job. But another situation is if the worker seems to be stuck or needs clarifications, in which case it should return. So there we go. Okay. And now to manage state. You remember with state, it can really be any Python object. It can be a Pydantic object, but we often use type dix, and that's what we're doing here. And now, for the first time, we have some real meaty information to store in the state. We've always had messages before, but now we have a real state, and we've got a bunch of things. We do still have messages, which is representing the discussion between the user and the assistant. But we've got other stuff, which is going to represent the information being passed from the evaluator back to the thing I'm going to call the worker, the assistant. And so we're going to have some more stuff. We're going to have success criteria, which is going to be set up front to define what does it mean to be successful. Feedback on the work, that's going to come from the worker. And by the way, you use optional like this. If this can be null, it can be none, or it can be a string. Success criteria met is a bool is true or false, and is going to be true if there has been a successful outcome, the criteria met, and it doesn't need to go back to the worker for more. And user input needed is if we need to go back to the user to get some more information. So that is our state. So it's a much meatier state. And this shows you that you can have whatever you want in the state. The state is really up to you and the flow of your logic. And that state is like something that is moved through the graph, and everyone gets their opportunity. Every node gets the state and gets its opportunity to return a new state that is some change to that state. And we're only specifying one reducer, add messages, which means that if one of these nodes returns with some messages, they will get accumulated. They will get concatenated with the existing messages. But if one of these nodes returns user input needed, that will overwrite whatever was in the old state. So when you return the new state, if you change one of these values here, that becomes the new setting for anything that is downstream of you in the graph. Okay, so next up, we set up our Playwright tools. This is the same code as before, using the async browser, the Playwright browser, and the Playwright browser toolkit. So we just run that. So that's pretty simple. And now we're going to have two LLMs that we're going to initialize. One of them is called the worker LLM. This plays the role of the assistant. It's going to be a GPT-4o mini, and it's going to be bound to those tools so that it will automatically have the JSON gumph in it. And then separately, we're going to have an evaluator LLM. This is a separate LLM, and it is, we're setting it up whereas before we said bind tools, and now we say with structured output and pass in the pydantic object. And that means that the response will conform to this output. Now, not all models are set up to support structured output. So you may find that some models can't do it if you're going to be playing around with different models. If that is the case, of course, the alternative to this is to do it the old-fashioned way, which means instead of using structured outputs like this and passing a pydantic object, you ask the model in the prompt to respond in JSON. You give it the schema. You list out what kind of JSON it should respond in. You maybe give a couple of examples to make sure that it's really biased to do well. And then you have to parse that JSON in the response. And that's all that is happening behind the scenes when we do structured outputs like this. So that means congratulations, you now learn how to do structured outputs with LangGraph. It's that simple. Okay, so this is a bit of a long-looking method function, this node, the def worker, which is representing our worker node, our assistant, but it's only long because we've got a lot of prompting in here. So it's a node, and so as usual, it takes a state and it's going to return a state. And you can see it's returning something with messages, and we know that messages accumulates because we have the reducer, so that is going to add on more messages. Okay, so we've got like a long system message. Let me talk you through it. We say, look, you're a helpful assistant that can use tools to complete tasks. You keep working on a task until either you have a question or clarification for the user, or the success criteria has been met. And this is the success criteria, and we take it from the state. It's something that should be held in the state. You should reply either with a question for the user about the assignment or with your final response. If you have a question for the user, you should need to reply by clearly stating your question. An example might be this. Now, it's not super necessary for me to have done that, but I wanted to make it really clear that it will say when it has a question and sort of force the point. If you finished, reply with the final answer and don't ask a question, simply reply with the answer. And I say that because these models love to reply with things like, can I help you with anything else? And that then might confuse our evaluator that's looking to see if it needs help. So I want it to be super clear on this front. Okay. And of course, all these things are subject for experimentation. There's no hard and fast rules. It's not like that is a rule that you have to put this in the prompt. I hope you know this by now. This is really the part of AI engineering that is about experimentation, R&D. You can imagine I've been crafting this prompt for the last couple of hours. So it's something that obviously you home in on something that works well. And you may find that particularly with different models, or if you have different assignments, it's something that you have to tweak to get the kind of performance you want. Anyways, if we've got in our state something in this field, feedback on work, then that means that an evaluation has happened and it's not gone well. There's been feedback and it's come back for more. So then we add to the system message. Previously, you thought you completed the assignment, but your reply was rejected because the success criteria was not met. Here is the feedback on why this was rejected. And then we give the feedback. And then with this feedback, please continue the assignment, ensuring you meet the success criteria. So there it is, spelled out in detail. Okay, and then I've got here some slightly hokey code that looks to see whether there's already a system message inside there. And if there already is, then it just replaces whatever system message is there with this system message. If it doesn't find a system message, then it creates a new one and puts it at the front. So this is just to make sure that we handle those various scenarios. Now, this is a little bit hokey because LangGraph will have already perhaps have built a system message. So we have to be a bit careful about this. And it might be worth doing some testing to make sure that it works for different models. Okay, so at the end of all that, we then call worker LLM with tools and we invoke the messages. We get back a response, and that is what we then return. So there we have it. Okay. Now, we now have something pretty interesting called the worker router. So the worker router then, it's a Python function that we will use in our edge, in our conditional edge, to decide which way to route control. And it's very simple. It's going to take the most recent message. It's going to see if it's a tool call. If so, it returns tools. If not, evaluator. And that is to say that when our worker, our assistant, has come up with an answer, if it's not involving a tool call, then it needs to be evaluated. And that's what we get to right now. So for the evaluation, we have, first of all, this little utility function, format conversation. That's just used to take in, I just wrote that to transform a list of these message objects into something which says like user assistant, in just a nice little text summary. And you'll see why right now as we come on to look at the evaluator code. We run these two cells and we will talk about the evaluator. So this is the evaluator, this function right here. It is a node. It takes a state and it returns a state. And it's meant to represent the LLM, which is going to be assessing our assistant, our worker, and deciding if it's ready to return to the user or it needs to go back for more. And so it all comes down to some prompting, and let me take you through it. Remember that we're using structured outputs that will require that the model returns a particular type of object. So first we take the most recent response, which is, of course, the assistant's attempt. We take that out of the state object, the messages collection. So then we come up with this system prompt. You are an evaluator, determines if a task has been completed successfully by an assistant. Assess the last response based on the criteria. Respond with your feedback and a decision on whether the success criteria is met and whether more input is needed from the user. And then the user message, this is going to be a bit more detailed. You're evaluating a conversation between the user and the assistant. You decide what action to take based on the last response from the assistant. The entire conversation with the assistant, along with the user's original request and all replies, is here. And this is going to use this little utility thing, which is just going to say like it's going to say user assistant with the whole conversation so far. So it's going to look very simple in language. The success criteria for this assignment is, and then I'm plucking out of the state this success criteria. And as I hope you've guessed, this is something that's going to be set right at the very beginning when we invoke the graph. So that's going to be passed in by the user and it'll be maintained throughout our graph. So we can pluck it out and just insert it in the user prompt for this evaluator right here. And then I say the final response from the assistant that you are evaluating is this last response. And of course, that will already be included in here. But I just want to be crystal clear so that the evaluator understands that it's not assessing the whole conversation. It's just assessing this response right here, which is what's going back to the user. Respond with your feedback and decide if the success criteria is met. Also, if more user input is required, either because the assistant has a question, needs clarification, or seems to be stuck and unable to answer without help. So you may remember that we already put some of this in the definition of the structured outputs of the response right up at the top. Let me show you that. Right here in the evaluator output, we already gave a little description of user input needed right here. And so you may wonder why I'm repeating myself here. And the answer is because there's never a harm in being repetitious with prompting. Be clear, be instructive, repeat yourself. These are good things to do in slightly different ways because it biases the model to doing what we want it to do. Okay, and then finally in here I put, if we've already got some feedback in the state object, that means that the evaluator was already called in this very loop and has already provided feedback in the past. And so I add in, also note that in a prior attempt from the assistant, you provided this feedback. If you're seeing the assistant repeating the same mistakes, then consider responding that user input is required. Now you might think this is very clever, like Ed, how did you come up with that? And why that? And when do I use this kind of thing? And look, the answer is there's no magic here. That is there because I was testing this and it kept messing up by the evaluators sending back the same problem again and again. And so this is the kind of thing that is trial and error. You experiment, you try. When something goes wrong, you change the prompt and you try some more. There's no magic and no clever rules to this. This won't always apply, but it applies here. And if you use a different model or slightly different tasks, you may find that you need to tweak this or use something different. And that is what AI engineering is all about. And that is what prompting's about. And so, yeah, the answer is it's research and development. Okay, we'll finish this off in just a sec. So we then put the system message and the user message, which is called a human message object, together into one list called evaluator messages. And it's confusing because we're using this concept of system message and user message in order to talk to an evaluator. And this isn't actually a human message. It's actually something where it's a user prompt, but it's a message that we have manufactured. But that's just really how you go about building system and user prompts using LangChain's constructs. This is a LangChain construct within LangGraph. And so, this is still achieving the same thing. All right. Now, we then take our LLM, which is the evaluator LLM with structured outputs. We call invoke with these messages. And what comes back will be an instance of that class evaluator output. It is that Pydantic object filled up. And behind the scenes, what's gone on is that it's been asked to provide JSON, and that JSON has come back, and that JSON has been parsed into this object. That's how it did it. And so we're then going to create a new state because we're meant to return a new state. And in that state, we're going to respond. We're going to add to the messages because remember, messages has the reducer. So whatever we reply here gets concatenated, accumulated with the existing messages. We're going to shove in there that the assistant is replying evaluator feedback on this answer and something in there. Then we're going to give some feedback. We're going to and so what we're doing here is we're taking the feedback from the Pydantic object and we're putting that in the state. We're taking the success criteria from the Pydantic object, putting it in the state, taking user input needed, taking it from the Pydantic, the structured outputs that came back, put it in the state and return the new state. Hopefully you followed all that. If not, you will when it comes together. And then we've got another of these router functions, root based on evaluation. If the success criteria is met, or if user input is needed, then end the super step. The super step is done. Controller's got to pass back to the user. In either of these two extremes, either we've done great or we've done horribly. Either of those extremes, we need the user to get involved again. But if we didn't meet the success criteria and we don't need help from the user, then it needs to be passed back to the worker. We need to cycle back. The worker's got to try again and improve on this, given this feedback. That is the whole idea. That is the workflow. And now we come to our graph. It's very simple. And all of this is pretty simple. I've been making a bit of a meal out of it, explaining this step by step and talking about prompting, but it's not that hard. If you go through it yourself, you'll see what I mean. So this is our graph. We're going to add our worker node. We're going to add our tools node and our evaluator node that we just built. Now some edges. We're going to have a conditional edge For the worker, we're going to use the router that we wrote, the worker router. If it returns tools, we're going to go with the node tools. If it returns evaluator, we'll pick the node evaluator. We're going to add another an edge that goes from tools back to worker again. Remember this one? When the tools finishes, it's got to route back to the worker. That's kind of hokey that you have to do that. You think it would sort of be done automatically for you, but you have to be clear. And then another conditional edge from the evaluator based on its evaluation. If it wants to go to the worker, we put it back to the worker. If we're done, we're done. And then we also add a start edge to bring us first of all to the worker. Let's run that and look at a picture of this. There it is. There it is. We have ourselves a true agentic workflow. There's the start goes to a worker. That optionally can run tools, which has to come back. There's a thick line. Optionally dotted line, an optional edge, a conditional edge is the word, sorry. It will run tool, and then it will definitely come back an edge. And then when it's done, this is shown as a conditional because it's only if it hasn't decided to run a tool, then it will come this way. And the evaluator chooses either to end in two situations, either success criteria is met or user feedback is required. And if not, it comes back to the worker, end or back to the worker. So this diagram hopefully has everything coming together for you. And now scroll back up in the lab and just take a look through those nodes again. And at this point, it should be like, got it. And hopefully you'll see that although I made a bit of a meal out of it, it is actually quite quick to build something like this. And you see one of Anthropic's agentic patterns loud and clear here, although it's a little bit more than one of their workflows because this has like an infinite loop in it. It can keep going and there's a lot of optionality here. So this is a true agent pattern because in theory, this could just keep running and running, and it has some sort of agency autonomy over what it does. And surely you're now thinking, well, I want to see this thing. And that is what we will do next. Okay, so first of all, we have a callback, a Gradio callback that Gradio will call into when we press a button, which will kick off a super step. So I've got this little thing here, which is a sort of cheeky thing that comes up with a thread ID, a random, big, unique number to make sure that each time that we bring up the interface, it's not going to continue the conversation from last time, or things can get quite hectic. So this means that every Gradio session is going to have a separate thread. This also means that we could actually run this and have multiple different people that come on and use the interface and each have different conversations, which is really cool. So it's not just going to be for us, this sidekick. All right, so then the process message async, this coroutine, as I should call it, this function. So first of all, it creates a config based on the thread code that we're going to give it. Then it sets the initial state. So first of all, the initial state is going to take the user's message, the message that comes in. That's going to be the initial message. It's going to take the success criteria as the success criteria from the user that the user is going to tell us what they see as being needed for success. And this state will go through all of the graph and it will be used by the evaluator. The feedback on work, this is what the evaluator can set. Success criteria met, this is false to start with. User input needed, this is false to start with. And then here it is. Here we do it. We take a graph, we call A invoke, we pass in the state, the initial state, we pass in our config, and we wait for that to come back. With what comes back, we then need to build the stuff that's going to appear in the Gradio user interface. We package up the user's message. We package up the last two things that will have come back. The second last one will be the assistant's reply, and the very last one is going to actually be the evaluator's evaluation, and we'll show them both coming so that they both appear in the UI, because it'll be nice to see the evaluation as well. But you could remove this if you don't want to see the evaluation in the UI. And then we package that together in the history with all of this, and that's what we reply. There is a little bit of a confusion here if you're following all this, that we're sort of combining Gradio's history with the history that's being stored in LangGraph's memory. It would probably be elegant, more elegant here to actually unpack the full history from the state, but that would start to get sort of messy. So I thought keep it simple. This is fine. And then I've also got a little callback called reset that just resets the interface. So we'll just run this. That ran quickly. Check I ran the other cells. I did. And now we're going to launch our user interface. This is going to be a UI for our Sidekick. Let's see what it looks like. Here we go. The Sidekick personal coworker. It's got a nice shade of green I got for this UI. And we can ask a question and we can put the success criteria. So we will ask our Sidekick the question, what is the current USD GBP exchange rate? And the success criteria is going to be an accurate answer. Simple as that. Let's see how it does. Here we go. Press the go button. Up comes a browser window. It's put in 1 as the amount, so it's driving this browser. It's looked for the dollar pound exchange rate. It appears to be on dollar euro. That's not a good sign. See what's happening back here. It's still processing. Wonder if it's going to work this out. Well, it seemed to do okay, but I don't see on the screen how it did that. Maybe that's down here, or did it make a mistake? Let's see. Aha. No, it got it right. I see it. Scroll down. For some reason, it was defaulted to euro, but it got the US dollar to GBP at 0.77463. And if we come back here, let's see what it said. It did say 0.77463, so it drove the user interface. It was a bit quirky there that it didn't pick the right currency, but it found the information. So the answer was the current USD to GBP exchange rate is approximately that number. The evaluator feedback from our other agent, the assistant provided an approximate exchange rate. However, the assistant should ideally note that it may change. So it gives some stern feedback there, but it still chose to return control to you. So it's unclear. It thinks if it met our needs completely. Nonetheless, we saw it working, but now we need to see in Langsmith whether the right messages were exchanged. Well, here we are in Langsmith looking at what just happened. It's worth noting that it cost us 19,000 tokens, or 0.2 of a cent, a 2/10, a fifth of a cent. So if we look here, we'll see that a lot went on, actually. Look at all of this stuff. So the worker called a navigate browser tool. It called extract text. It called get elements. So I guess, yeah, this is how it was doing its navigations and running. And then you can see down here that this is where these are all worker tasks, worker tools, worker. And then this is the evaluator getting called at the end, just as we would hope. And we can actually go all the way into chat OpenAI to see what message was sent to the evaluator. So here we go. So this is the result of that function that I belabored a bit earlier. System, you're an evaluator, determines if a task has been completed successfully. Assess the assistant's last response based on the given criteria. Respond with your feedback, blah, blah, blah. Human, you evaluate a conversation between user and assistant. You decide what action to take. And then look at this. This is that utility function that says user, assistant, assistant, assistant. And you can see that I made it just print tools use like this so that it's clear to the evaluator what's going on. The success criteria for the assignment is an accurate answer. So that's straight from the Gradio UI. And the final response that you're evaluating is that. That is the same, of course, as this. And then this is the respond with your feedback, blah, 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 blah. And we can see that what it responded with was JSON, of course, and it's JSON that conforms to the structured outputs schema that we provided. And that's why LangChain is able to read that in and populate that object. And that's what our graph then gets returned to it. And that is how the whole thing fits together. And there's the route based on evaluation taking us to the end. So it's kind of cool to see it here in Langsmith and see the trace through the agent flow. And I can tell you, obviously, I've done some experimenting with this, with some of my prompts didn't work so great early on. And there was times when there was like 25 different messages between the agent and the evaluator, particularly on some harder tasks. So it was quite interesting to see it bounce around and a lot of fun. And obviously improving the prompts is one way to get there. But overall, I see this as a really exciting project. You can really feel the beginnings of something very substantive here. And when you run this, you can experiment with giving it bigger tasks, asking it to summarize various websites, to navigate around and to summarize back something to you. And there's lots that you can do here, which is terrific fun. And so that's going to put this on pause for now, because when we come back tomorrow, we're going to try and make this into like a packaged project with a few more features. But let's go now to the wrap up. So I realized it was a long day today. We got through a lot, and I hope that you did have that same journey as me, as seeing the visual there of that LangGraph graph, and seeing the ability to build an evaluator and an agent that's able to talk like that and to go backwards and forwards, being able to give it Playwright and be able to operate Playwright like that. It's like we've built our own operator, the agent from OpenAI, or that we built like a Manus kind of agent. And it's been so easy to do it. And it's so cool to see the graph like this, to be able to interact with it in Langsmith. So as I said, I'm becoming a true believer. I'm becoming a LangGraph advocate. It's exciting to see it come together. And tomorrow we'll try and take it one more step forwards. See you then.